So we're working out of OpenStax Statistics, Chapter 9, and we're going to work through a hypothesis test with bride ages. Just as a reminder, you can always access the OpenStax text for free. Just look in the description of the video. And you can access the Excel workbook for free. Go to divideandconquermath.com and go to the OpenStax Statistics section. Okay, so for this one, we have that Joon believes that 50% of first-time brides are younger than their grooms. She performs a hypothesis test to determine if the percentage is the same or different for 50%. So Joon samples 100 first-time brides and 53 reply that they are younger than their grooms. So for the hypothesis test, she uses a 1% level of significance. And here we're going to compare p-values versus the critical value approach. And sorry, I have this written down twice, my bad. Okay, so first of all, I actually think that the way that this particular problem is stated is a little bit confusing because this is what Joon believes. 50% of first-time brides are younger than their grooms. And then in the next statement, it says test that it's the same or different. So you might read this and think like, oh, because it says they have to be younger than, that's how you're supposed to like set up your hypotheses. But this clearly states that she performs a hypothesis test to determine if it's the same or different, and the same or different would just be equals or not equals to. Now, in my Excel workbook, I don't have this written out. This would be something that I would have written on my paper. But you do need to know what the hypotheses are when you're setting up your Excel spreadsheet. So I always write this down when I make videos, but usually when I'm just doing this on my own, this is like something I have written on my paper. Now, the other thing I want to state here is that we have moved from the previous tabs, which are always talking about means. This is not talking about a mean. This is talking about percentages, proportions. So we are using kind of a different test statistic here, really. So it's the same logic as all other hypothesis testing. It's just a slightly different test statistic. So we once again, we want to do what we always do. So we want to just note what data we're talking about. So you have kind of your established P, and so that's going to be this P sub 0, which I'm going to write like this P sub 0. So the established P is exactly what we're working with from our hypothesis test. So that's going to be 0.5. Now, in this case, I don't have a standard deviation. Instead, I've been given information about how to compute the proportion that I am going to kind of compare with. So the way that we write that is we're going to have an X, an N, and then a P prime. So my X are what number responded that I want to use for my proportion. So that's 53 brides said that they are younger than their grooms out of 100 brides. So there's how I'm going to set that up. And then I'm going to have 53 over 100. That's going to give me my P prime. Okay. The other thing that you're going to need in this case is you are going to want to go ahead and compute your test statistic. It's just going to make our lives easier as we're working through this. So for my test statistic, well, that's why I actually wrote it out on the spreadsheet just so we could easily reference the formula. This isn't written on the spreadsheet that I have created, but it's something that you are going to need to know. So it's something that, again, I'd probably have written on the side. So I'm going to take this P prime minus my established P divided by the square root of, and so now I have to do a little bit of work for this. So this is going to be P prime times, or sorry, not P prime, P naught is what we would call that. Q naught is found by just taking 1 minus P naught, which in this case I know is 0.5, but I just want to stay consistent. And then I divide all of that by N. Okay, so there's my denominator for my test statistic. And so now we can get into our p-value versus our critical value approach. Okay, so first of all, when you're working with proportions, so this is kind of a longer explanation, but this is just kind of a reminder. So when you're working with proportions, you are really moving into the standard normal distribution. You don't have to worry about is this student's t or the normal distribution. So when you're working with proportions, it's always just the standard normal distribution. So you're going to have, it depends now on your approach, right? So you're going to have your p-value versus your critical value approach. Well, for p-value, I can go ahead and kind of draw the graph associated with this, but for critical value, I have a little bit more work to do. So for the critical value, I need to know what is my alpha. So in this case, I'm told that Joon is using a 1% level of significance, so that's going to be my alpha. But this is a two-tailed test, so I need to take that alpha and divide it by 2. And so then from there, I can find my critical values. So I'll use that norm.s.inverse function. And so here will be my critical value kind of on each side of my normal distribution. So from here, you should be able to draw kind of the graph associated with each of these situations. And then you should be able to make your conclusion for the test. So I would challenge you, even though you've maybe never done a proportion test before, like the logic works the same as the previous tabs. So maybe go ahead and draw each situation and make your conclusion and then hit play when you're ready. Okay, so if we're doing p-value, so remember this is a two-tailed test. So this p-value associated with this test statistic, I have to view this as only half of the p-value because this is a two-tailed test. So I just want to mirror that on the other side so that I can then find my p-value. So for my p-value, I'm going to do norm.s.dist. I'll use I'm going to use the test statistic. Now, the only thing is I want to be careful with how I'm thinking about this, okay? So if I were to just do norm.s.dist and just use the test statistic as is, oops, I put in too few arguments, sorry. Okay, so remember, this is always calculating strictly to the left. So if I have plugged in 0.6, this is not getting me the area that I want, right? I just need the area in this tail. So there's two ways that you can kind of handle this. If you want to use the test statistic as is, you can take 1 minus this to get the area from here to here. But then remember, you have to multiply all of this by 2. Or the alternative, which is what I'm going to do, is I'm just going to find the area from here, so this is negative 0.06 to the end of the tail. So I'm going to put a negative in front of my test statistic. This gives me this little piece of area here, and then I just need to multiply that by 2. So there's my p-value, which is huge. Versus with my critical value, so with my critical value, I found this critical value, but again, it's a two-tailed test. So I set up these two kind of cutoff points, and then I plot where my test statistic falls, so right here. And in either case, so you can see 0.6 is not in this reject zone over here, and 0.54 is clearly much bigger than 0.01. So in either case, you do not reject the null. You don't have enough evidence to suggest that the age difference is different from 50%.